In this video, we're going to take a look at another example to apply t-test and using critical region to make decisions about a hypothesis testing of t-test. So this one says a construction company purchases pins for use in several of their projects. These pins are supposed to have a mean tensile strength of at least 500 psi, but destruction testing is required to measure the tensile strength of a pin. We're interested in determining whether the mean tensile strength is less than 500 psi. So again, right here is giving you that your alternative hypothesis is mu less than 500 psi. And that's a one-sided test. Therefore, a sample of 12 pins are evaluated, so that's your n, and used to verify that the tensile strength is acceptable using a level of significance of 0.1, and that is alpha. Part A, state the null and alternative hypothesis. So that's the first step. H naught, or null hypothesis, is mu is equal to 500, and alternative hypothesis is mu less than 500. And again, I want to re-emphasize that your null hypothesis always has the equal sign. Part B, identify the test-stat and critical region for this test. Well, because this is a one-sided test of type less than, your critical region is going to be on the left tail of t-distribution. So if this is the t-distribution, this is going to be your critical region, and this point here is negative t of alpha and n minus 1. So part B, the test-stat is t-score. And the indication that we're using this t-test is that the standard deviation of the population is not given, it's unknown, and also the n is less than 30. So we're doing a t-test, and that is x bar minus mu naught over s divided by square root of n, and the critical region is when t-score is less than negative t of alpha and n minus 1. In this case, that is negative t of 0.1 and 11, because n is 12. That's your sample size. So we need to read this t value from the table that we will do in a second. Part C, suppose the sample mean, that is x bar, is 491.3 psi, and the sample standard deviation, S, is 13.2 psi. State and interpret the conclusion for this test. So we need to calculate the test-stat first by plugging in the parameters. X bar is 491.3 minus mu naught is 500, that's your hypothesized value, over 13.2 divided by square root of 12. And when you do the math here, you get negative 2.28. Now we need to find this critical value from the table and compare it with negative 2.28, see if we are in the acceptance region or critical region. So I'm going to go to the t-table. So here I am in the t-table, and we're looking for t of 0.1 and 11. So here is 0.1, and here is 11, degree of freedom. So this is the t-value we're looking for. So I'm going to go back. So here the t critical value is negative 1.363. And keep that in mind that what we read from the table was t of 0.1 and 11, which was 1.363. The critical region, because this test is a less than 500 test, is going to be when the t score is less than negative t of 0.1 and 11, which is going to be negative 1.363. So right here, we're going to end up in the critical region because this point, critical value is negative 1.363, and our test stat is less than that, somewhere here maybe, right? So since negative 2.28 is less than negative 1.363, we reject the null hypothesis. Rejecting the null hypothesis means what? This is the null hypothesis, and that says the mean tensile strength of these pins is 500 psi. Well, we rejected that. Based on the sample that we took, it looks like the mean tensile strength is less than 500. So we accept the alternative hypothesis.